Hi everyone, and let's get started, shall we? So today we'll be talking about elasticity. And to start with, we'll review some key concepts, which involves the meaning of elasticity, the determinants affecting elasticity of demand and supply, as well as the types of elasticity. And we'd like to review also about using a quick prediction formulas to help us back out the percentage change in price and the percentage change in quantity. Right, so we'll move on to the discussion question and attendance exercise afterwards, as usual. So let's start with the meaning of elasticity. So elasticity is trying to measure how responsive the quantity demanded or the quantity supplied is to a change in price. So let's take the demand side as an example. And we have a demand curve like this, for example. Suppose there is an increase in price, something like that. Okay, so with this small increase in price, as you can see in the diagram, the quantity demanded actually drops a lot, right? So this shows that the demand on this diagram tend to be more elastic, right? So the quantity demanded change a lot as a result of a price change, right? Sensitive to the price change. Well, another diagram here, okay, we have this demand curve. So with a change in price like this, right? The quantity demanded only drops a little. So the demand on the right-hand side here tend to be more inelastic, okay, or less elastic, right? Even with a huge change in price, the quantity demanded only drops a little. So this shows the meaning of inelastic, less sensitive to the price change, okay? So this what it means by the elastic and inelastic. And this logic also applies to the supply side. All right. So regarding the definition of elasticity, it is as follows: percentage change in quantity divided by percentage change in price. So this is kind of the definition of elasticity. As you can see here in the table here, we are trying to observe how a change in price affects the total revenue. And for this part, I will leave the details a little bit later during the discussion question 4. Okay, so I'll leave it a little bit later for discussion. And now we'll move on to the next slide about the determinants of elasticity of demand. So 5 points are listed here. The first one is availability of substitutes. So it's intuitive. So if there are more substitutes that you can choose from, then it's easier for you to ship away to consume the alternatives or the substitutes instead. So more substitutes, then there's more flexibility to adjust your consumption, so more elastic demand. Well, the second point about time horizon. So if you have longer time to adjust your consumption habit or your consumption pattern, then there will be more flexibility for you and hence more elastic demand. Okay, the third point about classification of good. So let me make up an example to illustrate this point here. Let us consider the demand for meat and the demand for chicken. And obviously, chicken is under the category of meat, right? Chicken is a more specific category than meat. So regarding the substitutes to these two goods, right? So when we're talking about the substitutes to meat, it could be veggie. While if we're talking about the substitutes to chicken, it could be much more. In addition to veggie, it could be other non-chicken meat. Let's say beef, lamb, pork, and so on, right? So as you can see, chicken, the more specific category, will have more substitutes and hence more specific classification, more elastic demand. All right, the fourth one, nature of the good, whether it is necessity or luxury. So if it is a necessity, let's say food, even when there's a huge change in price, you cannot reduce your quantity of consumption a lot, right? You still need to consume the food for your survival anyways. So this is why the demand for necessity tend to be less elastic. While for luxury, let's say jewelry, and you see that there's a slight increase in price, and you may say that, oh, then I just choose not to purchase it at the moment. It's not a must. So for luxury, the demand will be more elastic. Okay, And finally, about share of the budget or the purchase size. So if the good accounts for a larger portion of your budget, then the demand will be more elastic, simply because if it accounts for a larger budget, then you would be paying more attention about the price change. And this shows that you are more sensitive to the price change and thus having a more elastic demand. All right, so this is about the determinants of elasticity of demand. And we also have 4 determinants affecting the elasticity of supply. So the first one, changing per unit cost with increased production. If it requires a large cost to produce additional unit, this shows that it will be harder for you to produce more units. And this reflects that the supply will be less elastic, right? Harder or less flexibility for you to increase your quantity. Okay, so lower additional cost, more elastic, and vice versa. So second point, time horizon again. So this time you are a producer side, and imagine you are running a factory. So in the short run, if you like to expand your production, then you may only hire more workers. There's less thing that you can do. But in the longer run, you can do much more. Apart from hiring more workers, you can buy more machineries or even build a new factory plants to expand your production or your output. In a longer time horizon, there'll be more things that you can do to expand your production capacity. So more elastic supply in the long run. And the third point, share for market of inputs. So if you're the supply side in a goods market, you're actually the demand side in the factor or input market, okay? The demand side in the factor or input market, because you need the input to produce the goods, right? So if you are actually a main player in the input market, then if you would like to increase the production of your good, then you will need to buy more of the input. And this would lead to a huge increase in the demand for input, and thus a huge increase in the price of input. And this actually goes back to the first determinant about the increased production cost to produce more units, right? So if you are a large buyer in this input market, then it would cause a drastic increase in the price of input, and thus it will be harder for you to expand your production, less elastic supply. Okay, so largest share, less elastic, small share, more elastic supply. And finally, the fourth point, geographic scope. It is somehow similar to the classification of good in the demand side, right? So let me use an example to illustrate that. If we are talking about the oil supply of the world, simply you cannot have any other resources that you can draw from, right? It's hard for you to draw other resources to produce more oil. But if you're talking about the oil supply in Hong Kong, for example, if you like to increase the quantity or the output of oil in Hong Kong, then you can simply draw the resources from other regions, let's say other Asia countries or European countries, to use the resources for the output in Hong Kong, right? So this shows that it will be easier for you to expand production in Hong Kong, okay, the narrower scope. So finally, narrower scope, more elastic supply, and vice versa. And the next thing to review is about the types of elasticity. As we have just reviewed, the definition of elasticity is percentage change in quantity divided by percentage change in price. And if you decompose this thing a little bit, it will simply be delta Q over Q divided by delta P over P. And if you rearrange this thing a bit, it will simply be delta Q over delta P times P over Q. And this form is automatically the point price elasticity of demand here, right? Which is trying to calculate the elasticity at a particular point. And by the way, to relate somewhat back to your mathematics course that you might have taken, if you are taking the limit of the fraction delta Q over delta P with respect to delta P tends to 0, then it's simply the derivative dQ dP. But anyway, the knowledge in calculus is not required in this course, just to connect the mathematical techniques with the economic concepts. Okay, so second type of elasticity will be the price elasticity of demand. or using a midpoint formula to calculate the elasticity. So why do we need to do so? Imagine we are trying to calculate the elasticity of demand here, and we have 2 points on this demand curve. Okay. If you're using the blue point as the initial point to calculate the point price elasticity, then you have a specific P over Q. While if you're using the orange point as the initial point, then you have another set of P over Q. This means that even when you're considering two same points on the same demand curve, the point elasticity of demand would change. So this is not desirable, and this is why we would like to use the midpoint formula to tackle this issue. Instead of using only the initial point, we are taking the average between the new and old quantities, as well as the new and old price to calculate the elasticity of demand. Okay, so this would help the elasticity to be more consistent with each other when we consider two same points. All right, so the third one is a cross-price elasticity of demand. So for substitutes, it would be a positive cross-price elasticity, while for complements, it will be a negative cross-price elasticity. So why is that the case? So let me use substitutes as an example, and the example I used in the last tutorial would be Coke and Sprite. If the price of Sprite increases, then people will shift away and to consume less of Sprite and more of Coke, right? So this shows that the demand for Coke will increase, and thus the price of Coke as well as the quantity of Coke will also increase accordingly. All right, so as you can see, the price of Sprite and the quantity demanded of Coke would move in the same direction. So this explains why the cross-price elasticity for substitutes is positive. And similarly for complements, it is negative because the price and the demand for the complement move in an opposite direction. All right, and finally, income elasticity of demand. For normal goods, it would be a positive income elasticity, while for inferior goods, negative income elasticity. And the idea is basically similar, right? For normal goods, income and the demand for normal goods move in the same direction. So positive income elasticity, while for inferior goods, the demand for inferior goods and income move in an opposite direction. So negative income elasticity. While for income elasticity, we have one more specific category called luxury goods, and is represented by a situation where income elasticity is greater than 1. So it is kind of showing the case where the demand for luxury goods is sensitive to the income change. So this is why we put greater than 1 to capture the income elasticity of demand for luxury goods. All right, so the final thing is about the quick prediction formula. If the question gives you some information about the percentage change in demand or percentage change in supply, it would actually hint at using the quick prediction formula to back out the percentage change in price or the percentage change in quantity. So for more details of using this formula, I will leave it during a past exam problem, which is involving the use of this quick prediction formula. So I'll leave the calculation a little bit later, right? And at this moment, we'll move on to the discussion question. And so please take a look at this first. Okay, so hope you have some initial ideas. So for case 1, Annie drinks a cup of latte every morning without paying attention to the price. So this is actually about the demand side, right? Elasticity of demand. And what is the feature in this case? So the quantity of latte for any is fixed at 1, no matter what the price is. So this illustrating a perfectly inelastic demand, right? A fixed quantity demanded at 1. And let me go to case 3 first, which is the idea is actually similar. Joe places an order at the gas station, saying that I like 10 gallons of gas. So here, for Joe, the quantity demanded for gas is fixed at 10 units, right? So this, again, shows the feature of a perfectly inelastic demand, okay, with a value 0. So from here, we know that any price change will have no impact on the quantity demanded. So a graph of a perfectly inelastic demand would be like this, a vertical line. Okay, let me go back to case 2. Consider demand for Starbucks coffee. Suppose a price increase would cause all consumers to buy from Pacific Coffee, while a price decrease result in all consumers buying from Starbucks. So case 2 is showing that the consumers are very sensitive to the price change of the coffee, right? So this is illustrating a perfectly elastic demand, okay? The value of elasticity of demand will be 10 to negative infinity. Okay, so when the price increases a little, the quantity demanded drops to 0, while if the price drops a little, the quantity demanded increase a lot. Okay, it tends to infinity. And the graph for this case would be the horizontal line as shown. All right, so case 4, Jerry places an order at the gas station saying like I like $10 of gas. So how can you interpret this $10? This actually affects total expenditure on the good. And recall, for a unitary elastic demand, the total expenditure would remain the same at any point on the demand curve, right? So case 4 is actually illustrating a unitary elastic demand. The value of elasticity will be -1, right? Okay, so affects total expenditure along all points on this hyperbola for the unitary elastic demand. And finally, case 5, Tom's marginal cost of producing orange juice is MC equals to 9Q. If you're trying to plot this marginal cost curve in a graph, it's actually passed through the origin. And this illustrates that it's a unitary elastic supply, right? Because for linear upward sloping supply that pass through the origin, it must be unitary elastic along the whole curve. So this illustrates the case here. Elasticity of supply is given by the value 1. Okay, so that's all for question 1, and please take a look at question 2. All right, so for this question, we are trying to compare the elasticity of supply for the pairs of goods here. So for the first pair, lemonade versus ivory. So we will apply the determine about increased cost of producing additional units. So for lemonade, if you like to increase the quantity supplied of lemonade, you simply need more lemon and water, right? So they are more readily available and the cost will be rather low. But if you'd like to increase the production of ivory, it would be harder to extract those ivory, and it is also more costly to do so. So it will require a higher cost, and thus the supply of ivory will be less elastic. Okay, so using the determinant here, lemonade will have a more elastic supply than ivory. The second pair, short-run housing supply versus long-run housing supply. So we are using the determinant about time horizon here. So as we have just reviewed, in the longer run, we can do a lot more to increase the production capacity. So long-run housing supply will be more elastic than short-run housing supply. And the third pair, Hong Kong market for coal versus global market for coal. So it will be applying the determinant about geographic scope. So Hong Kong market is narrower scope than global market, right? So if you like to increase the production of coal in the Hong Kong market, you can simply draw the resources from other regions. But for global market for coal, it is hard for you to draw resources from other regions, right? So narrower scope, more elastic. So Hong Kong market for coal will have a more elastic supply than global market for coal. And among these three pairs, only the second one is the exception, that the second good is having a more elastic supply than the first good. Okay, so that's all for question 2, and please take a look at the following one. So we have two price quantity pairs here, right? And this is why we can use the midpoint formula to help us calculate the value of the elasticity. However, are we calculating the elasticity of demand or elasticity of supply? From here, we know that there's an increase in demand for good Y, right? So referring to the graph here, we are actually considering 2 points on the same supply curve. So this is why we are using the midpoint formula to help us calculate the elasticity of supply, right? So this is the idea. And the elasticity can be calculated as percentage change in quantity divided by percentage change in price. So for percentage change in quantity, it would be the new quantity minus the old quantity divided by the average between these two quantities. And we have the percentage change in quantity to be 5%. And on the same token, for percentage change in price, it will be the new price minus the old price divided by average between these two prices. We have percentage change in price to be 10%. And we are now ready to calculate the value of elasticity of supply, which is percentage change in quantity divided by percentage change in price. So 5% divided by 10%, we have the value 0.5. So this is actually representing an inelastic supply. Okay, so we are going to observe which of the following options reflect the inelastic supply. So A, the good is a habit-forming good. So this is actually about the consumption side. And imagine the example of cigarette, right? If you're consuming cigarette, you're addicted to it. So you have a habit of consuming cigarette. Even when there's a huge increase in price, you still would consume the cigarette because you're addicted to it. So this is reflecting an inelastic demand. All right. So for B, there are lots of substitutes for the good. So about the consumption side as well, and this is straightforward. So more substitutes for you, then easier for you to shift to consume the substitutes, right? More flexibility for you. So more elastic demand. And for C, firms producing the good have excess capacity in production. So imagine this excess capacity is storage, right? So if there's a slight decrease in price, then you as a producer may say that, oh, then I'll just hold the product and not to sell it at the moment. Then I just store the goods in the storage. Then it will be easier for you to adjust your output as a result of a change in price. So more elastic supply, right? The elastic supply for C. And finally, D, firms producing the good have used factor inputs which are more specialized. So for more specialized inputs, likely they are more expensive and more limited. So this shows that the production cost to increase your production will be larger. Okay, so less elastic supply or inelastic supply. And we'll move to the next one. Question 4. Please take a look. All right. So it says that if Typhoon in Utopia destroy half of the upcoming harvest of good X, how would the price and the total sales revenue of good X change? Okay. So when Typhoon destroy the harvest, then the supply of good X would fall. So this would lead to an increase in price of good X and a decrease in quantity traded of good X. Okay. So this completes the first part of the question. However, how does the total sales revenue change? It's uncertain because total revenue can be calculated as P times Q. One increase while the other decrease. We are uncertain about the overall change in total sales revenue. And in fact, it depends on the elasticity of demand. So if we are considering an inelastic demand, percentage decrease in quantity divided by percentage increase in price would be smaller than 1. I only consider the absolute value of the elasticity of demand. I do not take into account the negative sign, right? It's already incorporated inside the decrease here. Okay. So if it's an inelastic demand, then the percentage decrease in quantity would be smaller than the percentage increase in price. This shows that the increased part in revenue is greater than the decreased part in revenue. Then the overall change in total sales revenue would be an increase. And it is also represented in the left-hand side diagram here. The total revenue will increase with an inelastic demand. Well, if we have an elastic demand instead, then we just swap the inequality sign here. The percentage decrease in quantity divided by percentage increase in price would be larger than 1. And the decreased part in revenue will be greater than the increased part in revenue. So the total sales revenue will decrease under this case of elastic demand. And is also consistent with the diagram here. And anyway, we are uncertain about the overall change in total sales revenue in this case. All right, so that's all for this question, and we'll move on to the following one. Please take a look. All right, so hope you have some initial ideas. And let me explain statements 1 and 2 together, which is also about the downsloping linear demand curve. Referring to the diagram here, so for any points above the midpoint of this linear downsloping demand, it was said to be the elastic portion. For any point below the midpoint of this demand curve, it will be the inelastic portion, while for the midpoint, it is the unitary elastic demand. So statement 1, demand becomes more elastic as quantity increases. So this would be false. because as quantity increases, it will move from the elastic portion to the inelastic portion, right? It should become less elastic or more inelastic as quantity increases. Well, statement 2, any point on the demand curve above the midpoint is elastic. So this is automatically true after we review the feature of this demand curve. Okay, statement 3, supply become more elastic as quantity increases if it has a positive x-intercept. So let me use a little bit of math to prove this to you. Okay, so we are considering the elasticity of supply, delta Q over delta P times P over Q, and also the supply function P equals to A plus BQ, which is just in the form of Y equals to MX plus C. All right. So why do we need to do so? Because we would like to consider how a change in quantity affects the elasticity of supply. So we would like to have only one variable in the formula of elasticity of supply, and we would like to use P equals to A plus BQ, the supply function, to substitute away the variable P. Okay, so this is what I'm trying to do here. So for the first fraction of elasticity of supply, delta Q over delta P, it is simply 1 over the slope of the supply. And the so-called the slope of supply is the coefficient B here. So we have 1 over B, it's the first fraction. Well, the second fraction, nothing special. I just divide the whole thing by Q0. Then we have this bracket here. And the final step is to multiply 1 over B into this bracket. And we have the elasticity of supply to be A divided by BQ0 plus 1. So obviously for supply curve, the coefficient B should be positive, right? While for this case, we are considering a supply curve that has a positive x-intercept, something like this. So imaginary or mathematically, it should have a negative y-intercept, right? So this is why the coefficient A should be negative. So how can you interpret? As quantity increases, the first fraction here should be less negative. A less negative number plus 1 should be larger and larger as quantity increases. So this shows that the supply becomes more elastic as quantity increases. So this is why statement 3 is true. All right. And regardless of the intercept of the linear supply curve, we have the following property. When the quantity increases, the first fraction would approach to 0. This means that the elasticity of supply will tend to 1 when quantity increases. So we have the following property as I've put down in the last line here. Okay, and finally for statement 4, any point on the supply curve with a positive x-intercept is inelastic. So this is a good opportunity for me to review the feature of a linear supply curve. So if a upper sloping linear supply curve has a positive y-intercept, then it should be elastic over the whole portion. While if it has a positive x-intercept, then it should be inelastic along the whole curve, which explains why statement 4 is true. And finally, if the upper sloping linear supply curve passes through the origin, then it should be unitarily elastic along the whole curve. All right, so that's all for this question, and we'll move on to the following one. Please take a look. Okay, so we are comparing the elasticity of demand for each pair of the goods here. So let's see. For the first one, Avengers in cinema versus the Avengers online. So when we are talking about movies in the cinema, it will have less substitutes because it would be restricted to the film that is available at the cinema at the point of time. But for movies online, it will have more substitutes, right? You just go to Netflix and you can search for movies from many years ago, right? So this shows the movies in cinema will have less substitutes than movies online. So in cinema will be less price elastic than the demand for movies online. Okay, so the second pair, Pepsi versus tap water, and we'll use the determine about necessity here. So for tap water, it is a necessity for your survival, but Pepsi is not. So this shows that Pepsi should have a more elastic demand than tap water. While for the third and fourth pair, we will use about the classification of the good to explain this, the difference in elasticity. So for lettuce, it is obviously under the category of vegetables, while Kit Kat chocolate bars is under the category of chocolate bars. So for a more specific category, the demand will be more elastic. So the second good here will have a more elastic demand than the first good. So statements 3 and 4 are both true. All right, so this completes the question, and we'll move on to the next problem. Please take a look. Okay, so let's go through the background information. We know that the quantity supply is expected to increase by 270 barrels per day at any given price. Because quantity supply increases at any given price, this is illustrating an increase in supply, right? An increase in supply. And we can actually calculate the percentage increase in supply, which is 270 divided by the original quantity, 9,000. So we have the percentage increase in supply is 3%. Okay, with an increase in supply, we know that the equilibrium price would fall while the equilibrium quantity would increase. So this is how we can interpret the information at the moment. Okay, so with the information about percentage increase in supply, it will hint at using a quick prediction formula to calculate the percentage change in price. So how can I do that? It would be the percentage change in supply divided by the absolute values of elasticity of demand and elasticity of supply. So 3% divided by 0.5 plus 1.85. Then we have the percentage decrease in price to be 1.28%. And likely you may ask, shall we put the negative sign to calculate the percentage change in price here? Personally, I do not suggest you to do so because the negative sign is just to indicate whether the price increase or decrease. However, we can actually predict the direction of change using a technique that we have learned in chapter 4, right? So we just use this to check whether the price and quantity increase or decrease. We do not need to blindly memorize from the negative sign, okay? So this is why I only calculate the value instead of putting a negative sign here in our calculation. All right, so to better understand what we have just calculated, percentage change in supply is actually referring to here, right? The shift in supply, while the percentage change in price is actually about the percentage change in equilibrium price. Okay, so this is question 34. Well, for question 35, we are going to calculate the percentage change in equilibrium quantity, which would be here. And as you can see, percentage change in supply is different from percentage change in quantity. And how can we calculate the percentage change in equilibrium quantity? As you can see here, with the increase in supply, we are actually considering 2 points on the same demand curve. And we can use the elasticity of demand to help us calculate the percentage change in quantity. How can we do so? So referring to the formula of elasticity of demand here, we have the value of ED to be negative 0.5 directly given the question, while for percentage change in price, it would be negative 1.28 that we have just found in question 34. All right, so the only unknown in this equation is the percentage change in quantity that we are looking for. And solving this, we are able to find that the percentage change in quantity is 0.64. Okay, the equilibrium quantity will increase by 0.64%. All right, so hope you understand this, and we'll move on to the next problem, the last one in this tutorial. So let's start. For question 35, we're going to calculate the income elasticity of demand for good A. Recall that income elasticity can be calculated as follows: delta QA over delta I times I over QA. So for the first fraction, delta QA over delta I, it is simply the slope coefficient in front of I, negative 2.8. So why? Recall your high school knowledge in mathematics. Equation of straight line can be written as y equals to mx plus c, where m is actually the slope coefficient calculated as delta y over delta x, right? Change in y divided by change in x. So here, instead of y on the left-hand side, we have QA on the left-hand side, right? So we have delta QA, while the variable in consideration is I, right? The right-hand side variable in consideration is I, so we have delta I. So this y, the coefficient in front of I is automatically delta QA over delta I. We do not need to take the reciprocal of it. All right, so how can we find the variable I here? Although it's not directly given, we can actually plug in all the information here. Okay, all the price and quantity here back into the demand function. Then we will have the value of the income, which is 140. And finally, for QA, it is already directly given as 150. So we can use it directly. And we can calculate the income elasticity of demand to be negative 2.61. And finally, question 36, to calculate the cross price elasticity of demand for the good A with respect to the price of product B. So it can be calculated as delta QA divided by delta PB times PB over QA. The technique is essentially similar. For the first fraction, delta QA over delta PB, it is simply the slope coefficient in front of PB, 1.7. While for PB over QA, both are directly given, right? PB is 36, while QA is 150. So we can directly plug the information here to calculate the cross price elasticity, which is 0.41. Okay, so that's basically what I'd like to cover for the tutorial today, and it will be the time for the attendance exercise. So I will open sets C and D for you and to close the quiz at around 9:26, 5 minutes later. Thank you. 2 minutes left for the attendance exercise. Okay, so time is up and I'll close the quiz very soon. So thank you for joining the tutorial again and see you all next Monday. Goodbye.